Greetings, I'm Stanley and I am in charge of the HPLC components for Group Undecided, and I'll be running through the methodology employed in addressing the Capstone project. To start, HPLC stands for High Performance Liquid Chromatography, while MS stands for Mass Spectrometry. There are 5 components in the HPLC instrument. Firstly, a dual-cylinder pump is used to move the liquid. The pump is connected to 2 mobile phase solutions. The pressure and flow stabilized to avoid noisy data. Following this, the injection port. This is where the sample can be introduced with a syringe. An autosampler is also used to increase the efficiency of sampling, where instead of introducing the samples manually, the autosampler will automatically syringe the samples based on a batch input made on the computer, allowing for sampling to occur when operator is not present. The sample is carried by the mobile phase through a specialized column in a column oven to control temperature and perform liquid chromatography, or more simply, liquid separation. It is important to select the correct column for the task. The aim is to have the column not interact with the mobile phase solution, but interact with the sample which acts as a stationary phase, thereby separating different samples from each other as different particles are slowed by the column at different rates. For example, a reverse phase column can slow down the particles that are hydrophobic. It is also important to note that the solutions with solid particles or precipitates are not appropriate for HPLC, as they can damage the column or cause pump pressure and flow to become unstable. Therefore, the complete dissolution of samples is necessary. The first analysis begins with the solution now separated passing through the photodiode array detector, where light is shone through it in a flow cell and then absorbed light is measured. It is important to note that the compounds with good UV or visible light absorbance makes for easier detection, where otherwise HPLC-MS cannot provide for good detection of the analytes. The same solutions measured by the photodiode array then enters into the mass spectrometry, where it is ionized and the ions of different masses is measured for the mass to charge ratio. Simply, the combination of the two analytical techniques allows to determine the amount of light absorbed, then the mass of the ions that absorb that light. When performed on an unknown species, it does not amount to anything, where at best, guesses on what it is in the sample can be made based on the mass to charge ratio. It is vital a standard calibration is produced to allow for further analysis of the concentration. The internal standard is a solution with known quantities of a known compound, whereby analyzing the results of the standard calibration solution and comparing it to the unknown solution, can we then determine its concentration, purity, and content. For the Capstone project, we were tasked to verify the purity and dosage of naproxen, ibuprofen, and aspirin tablets produced by Kenso Farm Co., as well as the characterization and analysis of customer return aspirin pills, comparing the returned product to the powder ingredients seized by the Australian Federal Police during their investigation into the clandestine production of medicinal tablets, and determine the health risks it poses. In attempting to assist with the investigation, the HPLC-MS team aims to address the challenge of verifying the purity and dosage of the authentic pills, as well as determine if the naproxen pills are safe for consumption, as naproxen has 2 different versions, or enantiomers for the scientifically inclined. Alongside this, the HPLC-MS team aims to determine whether the returned aspirin matches the authentic aspirin tablets, and compare it to the seized powder to determine if there are similarities in ingredients as to prove clandestine production. Furthermore, powder can be characterized for suspected ingredients that can cause people to feel unwell, such as naphthalene. However, HPLC alone cannot completely prove their presence, but act as a supporting evidence to the contextual clues provided by the Australian Federal Police. The HPLC-MS is appropriate for addressing the described challenge of purity and dosage verification, as all the compounds that are planned for analysis can firstly be dissolved completely in methanol, which was used as the solvent due to its viability with HPLC-MS. In addition to this, the analytes are all respectively hydrophobic, allowing us to use a reverse phase column to separate them from the solvents as well as the other compounds. On top of this, all analytes are detectable by UV and visible light as screened by our UV-Vis team. The HPLC-MS is also distinctly appropriate for the determination of naproxen enantiomers, as chiral columns can be used to separate R-naproxen from S-naproxen. A comparison of the returned pills to the authentic and seized ingredients is also appropriate for HPLC, as to determine the similarities, where on the basis that the returned aspirin is the same as the authentic, the HPLC data should look highly similar in regards to ions and concentrations found, where otherwise there is a chance that it would share HPLC characteristics similar to the clandestine ingredients or otherwise. To summarize what was investigated by the HPLC-MS, we have the purity of authentic tablets when measured against an internal standard of varying concentrations, and the composition of safe naproxen to hepatotoxic R-naproxen in the authentic tablets. Briefly, the dosage of all pills was found to be higher than intended. The naproxen was found to be safe despite having a higher dosage, whereas both ibuprofen and aspirin has an overdose risk of about 5 pills in excess, with ibuprofen 1.4 times and aspirin 1.1 times higher than intended. For quality assurance, dosages were compared against a calibration curve with a pure analyte to determine only their respective amounts, with a mass-to-charge ratio assigned to their respective peaks. Quality control came from the appropriate use of single-channel pipettes to dilute the exact amount required. In investigating the purity, the total ion count of the samples with their respective analytes were compared against each other to see irregularities. Although further investigation will be required to determine some of the concerns, unknown powder B assigned with ibuprofen has noticeable impurities shown here at 2 minutes and 15 seconds, assigned for naphthalene, while the returned aspirin has a major unassigned impurity concern right before 3 minutes. Despite the returned aspirin having such impurities, no clandestine production can be proven as the seized powder assigned to the aspirin does not share its characteristics. Finally, naproxen samples have no particular concerns that are noticeable, though further confirmation will be required for the peak outlined. In regards to chirality, the S-naproxen was found to be the major enantiomer with no detectable signs of R-naproxen. No quality assurance was performed due to time limits, but good practice to be noted is performing more naproxen internal standards to properly assign the peaks. HPLC can be a highly selective instrument with flexibility to provide both qualitative and quantitative data on samples. The key strength of the HPLC was the ability to make a more direct evaluation of the compounds present in the analyte through mass spectrometry, allowing us to determine which retained peaks have which compounds, as well as more distinct evaluations of their respective concentrations, as the individual compounds of interest can be separated from other compounds. With regards to the challenges of the Capstone Project, this meant that the particular dosage and purity of the authentic pills can be determined all at once, as they can be compared to a pure internal standard. More importantly, when there are impurities, HPLC can distinctly separate it from the other analytes in question, and the mass spectrometry able to make a distinction of what it may be. However, this is simply only due to the context providing directions, where characterizing other compounds within the sample without context clues is difficult. For example, naphthalene was initially guessed to be the filling ingredient, however, without being clued into the smell, characterizing naphthalene would have been difficult, as noted with aspirin. The main weakness felt during this investigation lies in the time-consuming nature of the process, where for the analysis of a single data point, 6 to 7 minutes must be allocated for each sample. With the use of an autosampler, this issue was minimized. However, due to the short windows of instrument operation, the flexibility to make changes to either optimize the data or perform quality assurance was minimal, especially due to our understaffed team. As stated earlier, quality assurance could not be guaranteed from the diversity of internal standards performed, where experimental repeats were not performed either. The HPLC MS team was able to verify the dosage and purity of the authentic tablets of naproxen, ibuprofen, and aspirin, noting ibuprofen and aspirin having a higher than recommended dosage. HPLC has also determined that the naproxen pills are safe for consumption as there are no detectable signs of the undesirable R-naproxen. In regards to the seized powder, HPLC was only able to strengthen the suspected presence of naphthalene, while only being able to show the existence of impurities in the returned aspirin pills.